Example 3, part A, says sketch the curve y equals x squared upon 4x minus 3 by only finding where it cuts the x and y axes and by considering its shape. So it doesn't mention working out turning points in their nature. So let's first of all work out where it cuts the x-axis. So cuts the x-axis when we set y equal to 0. So replace y with 0, we're going to get 0 equals x squared upon 4x minus 3. Now, I know this doesn't seem obvious at this stage and it might seem strange what I'm about to do, but there's a reason why I'm going to do this and I'll explain that in about a minute or so. See the way we have x squared here? I'm going to rewrite that as x minus 0 all squared. Because hopefully you'll agree that x minus 0 in brackets is just the same as x, and then you square it, that's just the same as x squared. So I've just written it x minus 0 all squared. Equally, you could write it as x plus 0 all squared. But I'm rewriting that, and then upon 4x minus 3, and then copy down equals and 0. Now, we've got a product of two things equal to 0. So that means that the first bracket here must equal 0, or the second bracket must equal 0. So in other words, x minus 0 equals 0, or 4x minus 3 must equal 0. So solve the separate equations. We're going to get x equals 0, or x equals 3/4. Now, the curve cuts the x-axis at 0 and 3/4, but the reason I rewrote x squared as x minus 0 in brackets all squared is because the solution that comes from the bracket with the power of 2 is where the curve only touches the x-axis. Okay, that's really, really, really important. Okay, the solution which comes from a bracket with a power of 2 is where the curve only touches the x-axis. So the curve only touches doesn't actually cut through it, touches the x-axis at 0. However, the other solution is where the curve actually cuts the x-axis, cuts through it. So it's a very important distinction to make. Okay. This x minus 0 all squared, that's called a repeated factor. So when you solve an equation, the solution you get from a repeated factor is where it's only going to cut the x-axis, touch the x-axis. It's only going to touch the x-axis at 0 here. Okay, let's get where it cuts the y-axis. So cuts y-axis. We're going to set x equal to 0. So go back to the equation, replace x with 0. So we're going to have 0 squared times 0 minus 3. So it's all going to just be 0. So y is just equal to 0. And then what about its shape? It says also consider its shape. Well, if we copy out the equation, y equals x squared upon 4x minus 3. If we multiply out the brackets, so we're going to get y equals 4x cubed minus 3x squared. Now, what we have is a cubic, with more than one x term and the coefficient of x cubed is positive. So remember the shape, if it's a cubic, it's got more than one x term, coefficient of x cubed is positive, then its shape is going to be up, down, up. Okay, so cubic with more than one x term and coefficient of x cubed is positive. So it's going to go up, down, up. So we've now enough information to sketch without having to calculate the actual turning points and their nature. So let's get our sketch. Okay, so we know its shape, up, down, up. We know it only touches the x-axis at 0, so it doesn't cut through it, it just touches the x-axis at 0. We know that it cuts the x-axis at 3/4, so say roughly there's 3/4. And it also cuts the y-axis at 0. Now, it's got to go up, down, up. So it can only touch the x-axis at 0. So it's got to have its turning point here. It's got to just go up and touch without cutting through the x-axis. So it's got to go up. Then it's going to touch the x-axis at 0 and cut through the y-axis at 0. It's going to go back down. So it's got to have another turning point, and it's got to come back round so that it can cut again at 3/4 and go up like that. That's the only possibility there. Okay, so that is our curve y equals 4x cubed minus 3x squared. Okay, so that is part A. Part B then says, sketch the straight line y equals x on the same axes and find the x coordinates of the points of intersection of the line and the curve. So y equals x then. So y equals x, again, is going to be a line that goes through the origin, slopes, it's going to slope upwards. So it's going to look something like that. There's your line, y equals x. Positive gradient, coefficient of x is positive. It's going to slope upwards, and clearly it's going to cut at one point there. It's going to cut at the origin. And there's going to be another point of intersection somewhere down here as well. So there appears to be 3 points of intersection there. With the line and the curve. Now in part B it says find the x coordinates of the points of intersection of the line and curve. So part B, so part B, so we need the x coordinates of the points of intersection. So we have our straight line, y equals x, and we'll call that equation 1. And then we have our curve, y equals, so if I multiply it out, that's going to be 4x cubed minus 3x squared, and that's equation 2. So to get the x coordinates of the point of intersection, remember, make y the subject of the line and then sub it into the curve. So that's, y is already the subject of the line, so we're going to chuck it into the curve. So sub line into curve. So we're expecting 3 solutions here because from our sketch there appears to be 3 points of intersection. So replace y with x here, so we're going to get x equals 4x cubed minus 3x squared. Then bring x over, so we're going to get 0 equals 4x cubed minus 3x squared minus x. We now have to try and factorize. Now it is a cubic, but thankfully there's an x here that's common, so we can lift out x. And it's not fully factorized because we need to factorize inside the brackets. So product here is minus 4, sum is minus 3. So the 2 numbers that would make that possible would be minus 4 and plus 1. So break up the middle x term in the brackets. And then factorize in pairs. So we can lift out 4x. So we're going to have x minus 1. And then we can lift out plus 1. Again we'll have x minus 1. And then tidy it up. So we've got x minus 1 is what we're going to lift out, that's common, and then we're going to have 4x plus 1. And then remove the outer brackets, so we're going to get 0 equals x upon x minus 1 upon 4x plus 1. So we've got a product of 3 things equal to 0, so that means x must equal 0, or this first bracket could equal 0, so that means x would equal 1. Or this third bracket would equal 0, which means that x would equal minus a quarter. So as we suspected from our sketch, there are 3 points of intersection, which means these are the x coordinates of those points of intersection. So 0, 1 and minus a quarter. So it wouldn't do any harm to put those on our sketch. So if we go back to the sketch, so there's 0, and then this point here has an x coordinate of 1. So we'll put that on our diagram. And then minus a quarter. And then 0. Okay, so it's a good idea to put those on. Now we're ready to have a look at part C. So part C then says, find the area enclosed by the line and the curve between the origin and the point of intersection with the positive x coordinate. Okay, so what that means is, if we go back to the sketch, we want to find the area which is enclosed by the line and the curve between the origin and the point of intersection which has a positive x coordinate. So that's the only point of intersection with a positive x coordinate. This point of intersection here is a negative coordinate. So if I shade it in, this is the area that we're looking for here. So before we use our little formula, we need to identify what's on the top and what's on the bottom. So clearly underneath the area is the curve. So that is on the bottom. Then above the area is the line y equals x. So that's on the top. And then we need the limits. Remember, the limits are the values of x that the area lies between. So the area lies between 0 on the x-axis and 1 on the x-axis. Those are going to be the limits of our integral. So we're pretty much ready to calculate the area. We've got the limits, we've got the top and the bottom. So let's go back to part C. So we'll write down our formula first. So remember, area equals the integral of the limits b and a of the top in brackets minus the bottom, close brackets, dx. So let's chuck everything in. So we're going to integrate. So quick reminder, the limits are, remember, the area lies between 0 and 1 on the x-axis. So 0 and 1 are the limits for x. So we're integrating between 0 and 1, open brackets. The top, remember, so what is immediately above the area is the line y equals x. So we sub in the non-y terms of the top equation. So we're just subbing in x. Close brackets, subtract, and then open brackets, bottom. So again, what curve is immediately below the area? So immediately below the area is this curve here, which is y equals 4x cubed minus 3x squared. So again, we're going to sub in the non-y terms of that curve. So 4x cubed minus 3x squared. So 4x cubed minus 3x squared, close brackets, dx. So it's really just what we've been doing before. So we need to get rid of the brackets first. So we still copy down the integral signs. So we've got x minus 4x cubed plus 3x squared. And now we're good to go. We're good to actually integrate now. So put our square brackets in because we're integrating with limits. So add 1 to the power, divide by the new power. So we're going to have x squared over 2. Copy down our minus. Add 1 to the power. So we're going to have 4x to the power of 4 divided by the new power, which is 4. So we're just going to be left with x to the power of 4. Add 1 to the power, divide by the new power. So we're going to have 3x cubed over 3. So the 3's cancel. So we're just going to be left with x cubed. And then add a constant, and then close our brackets, and then put the limits immediately outside. Okay, next plan then. So break up the square brackets into 2 separate square brackets with a minus between them, and then sub the bigger limit into the integrated expression in the first square bracket. So we're going to have 1 all squared over 2. Subtract 1 to the power of 4 plus 1 cubed plus c, and then we're going to sub the smaller limit into the integrated expression in the second square bracket. So we're now going to have nothing squared over 2 minus nothing to the power of 4 plus nothing cubed plus c. So let's tidy up. So first square bracket, we're going to have, well, we could probably do it all in one go. We've got a half here. 1 squared is 1 over 2. We've got a half minus 1. 1 to the power of 4 is just 1. So a half minus 1 is minus a half. And then 1 cubed is just 1. So minus a half plus 1 is just going to give us a half. So we've got a half plus c. And then we're subtracting. We're going to have nothing plus c, and again the c's always cancel out, so we're just left with a half minus nothing, which is going to give us a half units squared, and that is the area between the line y equals x and then this curve here, y equals 4x cubed minus 3x squared, between 0 and 1 on the x-axis.